A, we love math. A, we love math. A, every time we divide, we already know the path. A, then we multiply. All we gotta do is roll the die. A.
Hey math lovers, let's go over 1.5, solving quadratic equations by completing the square. So remember, we're still focusing on quadratics. And if I draw a coordinate plane, and then I draw a parabola here, remember the big idea is to find the solutions, the x-intercepts there, and the red dots. That's all like really what we're doing here with these different types of methods. I kind of say it's kind of like taking a potato. How do you cook a potato? You can fry it, bake it, boil it, broil it, barbecue, grill it, I don't know, bunch of ways, right? Okay, what's our standards for mathematical content? You can solve quadratic equations with real coefficients that have complex solutions. Use the process of factoring, and something we're going to do is called completing the square in a quadratic function to show zero, extreme values, and symmetry of the graph, and interpret these in terms of a context, or like a story or real life. So how can we meet these standards? I can use the square root property and complete the square to simplify quadratic expressions and solve quadratic equations with real and complex solutions. All right, let's go now to our standards for mathematical practice. How can I use these practices? Well, math practice number 1, make sense of problems and persevere in solving them. I can check my answers to problem solve by completing the square using a different method. Math practice 7, look for and make use of structure. I can look closely to discern a pattern for factoring expressions by completing the square. Our learning targets in this lesson, students will learn how to simplify quadratic expressions and solve quadratic equations by using the square root property and completing the square. By the end of this lesson, students will be able to answer the following questions. How can a quadratic equation be solved by using the square root property? Number 2, how can a quadratic equation be solved by using the method of completing the square? And number 3, how can writing quadratic equations in various forms help solve real-world problems? Go ahead and try the warm-up and then press play when you are ready to check your answers. Okay, for question number 1, I'm going to be using the X box method. And just a quick reminder that it's just A times C, your B value goes there, and when you have your trinomial, you'll put it into the box and you'll factor to the outside. Okay, so this again is from standard form, so I'll just put that there. So in this problem, A is 1, B is 2, and C is 1. So now I'll use my X box. Okay, A times C is 1 times 1 is 1. My B value is 2. Two numbers that multiply be 1, but add be 2 are 1 and 1. This is splitting the middle term, so I'm going to add an X here, and those go in the bottom left and top right, always. The A term always goes here, and then the C term goes here at the bottom. Let's now take the greatest common factor. I have an X for that row. This column is also an X. The row going left and right is going to be a positive 1, and this column is also going to be a 1. So we can factor that to be x plus 1, x plus 1, but they're identical, so we can just write x plus 1 squared is our answer. So the same thing for number 2. A is 1, B is 12, and C is negative 36. Remember, the A, B's, and C's will never have an X in it. Never. Okay, so now let's just go ahead and put into our X in our box. So A times C, that would be negative 36. And my B value down here is going to be 12. The factors of 36 are 36 and 1, 18 and 2, 12 and 3, 9 and 4, 6 and 6. Do you see 2 of those that will add to be 12? Yeah, so I'm going to write 6 and 6. Remember, those in red are splitting the middle term. That's why 6x and a 6x equals 12x. That one will always go in the top left, and this one will always go in the bottom right. Let's go ahead and factor here. Here, I'm just taking out the greatest common factor. So going the top row here, the greatest common factor is an x. In this row, it would be a positive 6. Going this direction, that'll be an x. And going in this direction, that'll be a Oh, see what happened? I made a mistake. Should have been negative, right? Let's double check. Maybe I wrote the original problem wrong. Negative 12 plus 36. Come on, Mr. Ring. That was the original one. Okay, let's try that again. So positive 36 and a negative 12, then it would be negative and negative. So this one would be a negative, negative 6, and then going this direction would also be a negative 6. So again, you have the same thing written twice. So that would just be quantity x minus 6 squared. Okay, let's try number 3. Same thing. A, B, and C. So A times C is 81, and my B value is 18. It's going to be 9 and 9. 9 times 9 is 81, and 9 plus 9 is 18. It's going to split this term, always in the bottom left, and always in the top right. That one will always go in the top left, and this one will always go in the bottom right. Greatest common factor of that one is going to be x. Going this direction, GCF is a positive 9. This column is going to be an x, and this is going to be a positive 9. I wonder if you guys see a pattern here. X plus 9. How many do you have of those? 2. Fancy word of that, you could say, is also multiplicity. Okay, let's do the same thing over here. I wonder what's going to happen. What do you think? Oops, that was a positive 121, negative 22. I think they're going to be identical numbers. What do you think? So negative 11x, add an x to it. So always go in the top left. This one will always go in the bottom right, always. And then what they have in common there is an x, negative 11. You might be asking, how is that a negative? It's negative 11 times negative 11. Does that make sense? This direction is going to be an x, and then this direction is going to be a negative 11. So x minus 11. How many do you have of those? 2. And the last one, number 5. Okay, so we have A is 4, B is negative 20, and C is 49. A times C, I'm breaking my calculator out, 6 extra 3, 196. And my B value is negative 28. Well, I'm just going to follow the pattern, so what's the square root of 196? That's what I'm going to do. And it's 14, because you can have done 196, and just keep breaking it down. I mean, 196 divided by 2 would have been 98. Here's my trick. I'll show it to you. In your graphing calculator, go to y equals, type in 196 divided by x, and then go to table. And hopefully it's on table set where it's changing by ones. So if I take 196 divided by 1, your answer is 196. Divided by 2 is 98, 4, 49, 7, 28. Does that make sense? What it does is finding all the factors for you. You don't have to think about them. 4, 49. I'm just going to put this over here so that's switch back. 196 divided by x. 7 and 28. You also notice I like to write the larger number on the left-hand side. And I'm only looking for whole numbers, not those with decimals. And then the numbers would just switch. 7 times 28 is the same thing as 28 times 7. Okay, so now we're just going to find the one that is what? And I'll put negative, and remember you're splitting this term right here, so you can add an x, negative 14x, negative 14x. I'm trying to write my x's a little bit nicer. Then I have 4x squared and 49. GCF going this way, pay attention, is 2x. Going this direction, minus 7. This direction, 2x. Because 2x times 2x is 4x squared. Remember how to check your answer? You just multiply on the outside. This one will be minus 7. So our answer is going to be 2x minus 7. You have 2 of those, so I'll get squared. Okay, let's go on to our launch number 1. Contains 5 white parabolic arches in the middle of the center 6 exposition halls. The 100-foot tall arches are lit with various colors to correspond to special events throughout the year. You can write quadratic equations to model the arches and to solve to find where each one meets the ground. Go ahead and click this GeoGebra, and we're going to slide the middle coefficient so it says 8x. The middle one is going to say 8x, and we're going to press start animation, and the red box needs to be blank in order to complete a square. So let's go ahead and click on this. I'm going to move this to where it says 8x, and it's going to do some really cool animation here. Looks like it's split the 8x into the green ones, so there's 4 x's there, and then this would need a square of 16. Slide the middle coefficient so it says 10x. Before you press start animation, predict that the red box needs to be blank in order to complete the square. So let's just move it over 1. And what do you think? Think about what is half of 10. And then there's going to be 5 greens. And then 5 times 5 is what? So here it is. So that expression on the side is x plus 5, and then 5 squared is 25. Okay, let's click on the second one over here. It's going to say change the b value to 4, then c needs to be blank in order to complete the square. So it's this one. Let's change our b value. Hey, what? There it is. Okay, there it is. So you have an expression called x squared plus 4x. You're going to split the 4x to be 2x and 2x. And so we need to complete this little green square, but this one's too big, so it's going to have to be what number? It's going to be 4. We need to put in 4 there to complete the square. Okay, predict, meaning you can put in for 6 for the visual and then see what you need. If you put in b equals 6. Let's put in b equals 6, so here's my b value. If you notice that it's always doing it evens, what do you think goes there? And then you can just use this visual. The numbers, well, 17 is too big. That number is, can't get it, 9. Because if you factor this, you'll get x plus 3, x plus 3. Oh, look at that, guys. That is our Xbox method. Oh my. All right, here's our answers for launch number 1. We have 5 white parabolic arches. These arches are 100 feet tall, so it's about 10 foot per story. It is 10 stories high. That's pretty tall. And it's quadratic. And we just did the algebra tiles. That one is 16, 25, and the other one is 4 and 9. Okay? Let's go ahead and go to some vocab. A process used to turn quadratic expressions into a perfect square trinomial. So we kind of did that. We did something that looked like this, right? You had a square, and then based on how many of these you put in there, it's probably a bad picture. Should be that should be like 4, right? So that red box, that is called completing the square. Okay, this one's new. A quadratic form written in the form f of x equals a times x minus h squared plus k. This is called vertex form. Vertex form. The order pair h comma k is equal to the vertex. Remember, that is the minimum or the maximum, right? And then the last one over here is problems that involve objects being thrown or dropped. So let's just say you go on top of the entire state building and you just decided to drop this. They call these projectile motion problems. Okay, so that is going to be 1.50 introduction.
Remember not to write all your math papers in ink. Remember to show all your work if you don't want to see. Remember to test, stay, and prepare for it wholly. Because if you don't, then you'll perform poorly.